Hey, I'm Alex. I'm here at Aeroscope Labs, and we have a Redbot robot by Sparkfun. We're going to hook up an Aeroscope and show you how you can monitor some of the Redbot signals remotely. We've attached the Aeroscope to this Redbot. We're using a Velcro strap. You could also use a zip tie or some VHB double-sided sticky tape. We're using the mini grabber accessory tip to monitor signals on the Redbot. Right now we're going to be looking at the motor controller PWM signal. Sparkfun Redbot is following this black line of electrical tape using the IR sensors on the front of the robot. We have Aeroscope monitoring the right motor PWM control signal. And you can see that as the robot makes a right turn, the PWM signal for that right motor drops way down. When it's driving straight or left, we can see that it's getting more power to that right motor and cutting the power for the right turns. We notice that the slope on the top of these PWM signals isn't constant. You can see that it's sloping downward over time and not being flat as you'd expect. This confused us at first. We think this may be due to the 5-volt rail. Let's investigate further. We're monitoring the 5-volt rail, and we can see that it isn't stable. It seems to be drooping down when the motors are turning on. I think that this is probably what's causing that issue with the PWM signals. Let's zoom in and check this out further. First, we're going to AC couple the signal. Then we're going to zoom into a finer voltage resolution. Move the trigger down. Now we can see that it's about 400 millivolts peak to peak of droop on that 5-volt rail. So it's clear that the droop on the PWM signal is related to the battery voltage drooping with increased current. This isn't a problem necessarily on this product, but if you were worried about this, you could use a battery with a lower ESR so that rail would be a little stiffer. We hope that this demonstration has illustrated to you how useful it is to have Aeroscope embedded on your project as it's driving around. If you were using traditional tools, you would be at a bench with an elaborate test setup, maybe using your fingers to fake out the IR sensors so you can measure those PWM signals. Thanks for watching.